All right. So we start with 12.1 today, systems of linear equations. When a system of equations has at least one solution, it is said to be consistent. If a system of equations has no solution, it is called inconsistent. An equation in n variables is said to be linear if it is equivalent to an equation of this form. So a system of equations has linear variables, and remember, linear means to the power of 1. So it could look like x plus y plus z equal to 0, and each of these variables is to the power of 1. It could even be x equals a number. Let's just say x equals 1 or y equals 2. So these are linear equations because the variables are to the power of 1. Okay. If each equation in a system of equations is linear, we have a system of linear equations. And the graph of each equation in such a system is a line. So a system of two linear equations containing two variables represents a pair of lines. The lines will either intersect, are parallel, or will be the same, coincident, identical. If the lines intersect, the system of equations has one solution and is called consistent. If the lines are parallel, then there's no solutions because they don't intersect, and this is going to be called inconsistent. And if the lines are coincident, then the system of equations has infinitely many solutions because the equations are the same, they lie on top of each other, and they intersect at every point. So that's consistent, and the equations are dependent. Okay, so here is a consistent system with one unique solution where the lines intersect. Here is a system that's inconsistent where the lines are parallel and don't intersect. And here is a system where the lines are the same, they are coincident, and this is infinitely many solutions. Okay, so in order to solve a system of linear equations, there are four ways. One of them is by graphing, one of them is by substitution method, one is by elimination method, and the fourth is by matrices. So we will get into all those methods today. Okay, so first we will start with graphing a system of linear equations. All right, here we're given two equations in our system, 2x plus y equal to -1, and -4x plus 6y equal to 42. Let's go ahead and graph these equations. So let's look at equation 1. So we'll call that one equation 1. 2x plus y equal to -1. Now, in order to graph this, we're going to go old school. We're going to go with the slope-intercept form. Remember, slope-intercept is y equals mx plus b. So all we have to do is rearrange this equation to solve for y. We'll get y equals -2x minus 1, where the slope is -2 and the y-intercept is going to be at 0, -1. Okay, so graphing that to the right, we'll start at that y-intercept of -1. And if my slope is negative, remember negative slopes go top left to bottom right. So if my slope is -2, we'll go down 2, right 1, down 2, right 1, down 2, right 1. And then I'll go the opposite way, starting at my y-intercept, up to left 1, up to left 1, up to left 1. And just connect. Let's see. Maybe I'll finish it off because I think I need to. Up to left 1, up to left 1, down to right 1. Okay. Almost perfect. Okay. There's equation 1. And now equation 2 is -4x plus 6y equal to 42. So let's do the same thing. Solve this equation for y. Move that 4x over to the right side, and then divide everything by 6. Y equals 4, 6x plus 7. And we know that 4, 6 reduces to 2/3 x plus 7. Oh man, it's coming down now out there. Woo. Okay, where my slope is 2/3 and my y-intercept is at 0, 7. So that's what we'll do. So 7, 1, 2, 3, 4, 5, 6, 7. And then since my slope is a positive 2/3, remember positive slopes go top right to bottom left. And if my slope is 2/3, I go up 2 over 3. 1, 2, 3. And then I'll go down 2, 1, 2 over 3. Hey, look at that. We land on a point that we share with equation 1. And then let me finish this off. Down 2 over 3. That's good enough. And boom. Okay. So we see that these lines intersect. So this point of intersection is the unique solution to both equations. And this happens to be at, what's that? 1, 2, 3. So that's -3. And then 1, 2, 3, 4, 5. So this is at -3, 5. There is our unique solution. If we were to plug this equation into both equations in our system, then it would hold true. So let's just go ahead and double check that really fast. We'll say check. So plug into the first one. 2 times -3 plus 5 is equal to -1. -6 plus 5 is definitely equal to -1. Check the second one. -4 times -3 plus 6 times 5 is equal to 42. You'd get 12 plus 30 equal to 42, and it checks out. Okay, excellent. So this is solving a system of 2 linear equations by graphing. Everybody good with that?
Yes.
Yep.
I do have one thing though. If the chance of this thunderstorm cuts out power, do we just revert back to the online or?
Yes, because that means I'll probably be out of power. You'll be out of power. So if it does, just watch the online lecture and we'll be back on Wednesday. All right. Okay. So now we want to solve these systems by substitution method. All right. So the way you do substitution is given 2 of these equations, you're going to pick one. You're going to pick one equation to rearrange either for x or for y. And the way to pick these equations, well, you want to pick the easiest one. So here, given our system of 2 equations, I'd say we want to rearrange the first equation and solve for y. And after we rearrange the first one, we are going to plug it into the second one for whatever variable we rearrange it as. We rearrange it for. And it can go the other way. I can take equation 2, solve it for x or y, rearrange it for x or y, and then plug it into equation 1 for x or y. So substitution method goes both ways. Okay, so looking at our problem, it looks like we can take equation 1 And let's go ahead and solve this equation for y. So I'll say, oh, I should just put it here. We'll move that 2x over, and we'll get y equals negative 2x plus 5. This is our sub. What we're going to do next is take equation 1 and plug it into equation 2. So we're going to plug this in for y into equation 2. All right. Uh-oh. It's hailing. Yeehaw. All right. I'm going to leave that there. So what we're going to have is that negative 4x plus 6 times my new y value of negative 2x plus 5 is equal to 12. Okay. And I guess we can make this a step. We'll say plug equation, actually I'll say plug y into equation 2. Okay. And now let's go ahead and simplify this. We'll get negative 4x minus 12x plus 30 is equal to 12. Put your like terms together, and we got negative 16x plus 30 equal to 12. Move the 30 over, and we get negative 16x is equal to negative 18. Divide by negative 16, and negative over negative makes positive. So we'll get 18 over 16, which reduces to 9 over 8. So x is going to be 9/8. All right. So once we find x, the next thing we're going to do is solve for y. We're going to solve for y because we know x is equal to 9/8. And this is set up perfectly for us because we already made a substitution for y. So that's what we're going to plug into. Y is equal to negative 2 times that x value of 9/8 plus 5. Simplify, and we're going to get negative 9 over 4. So this 8 becomes a 4. That 2 becomes a 1. We get negative 9/4 plus 5. And then put your fraction, put negative 9/4 with 5, add those two together, and that should give me 5 times 4 is 20, and 20 minus 9 is 11. So we should get 11 over 4. Okay. So here is our solution. Okay. So whenever we state our answer, we have to state it as a coordinate pair. So we say the solution is going to be the coordinate point of 9/8 and 11/4. And the reason we state it as this is because at this one point, these two equations will intersect. All right. Everybody good with that one? Let me see those thumbs up. All right, good. No talking, just thumbs up. Again, so that's substitution method. You rearrange equation 1 for x or y and plug it into equation 2. Or you rearrange equation 2 for x or y and plug it into equation 1. So that's how we work substitution. Okay. 2. 5x minus y equals 21, and 2x plus 3y equals negative 12. Okay, so we want to solve this by substitution also. So let's go ahead and just change things up. Let's go ahead and rearrange equation 2 and plug it into equation 1. Why not? Just to change it up a bit. And let's solve this one for x. Why not? Here, if we solve this for x, we'll get 2x is equal to negative 3y minus 12. Divide by 2, and we'll get x equals negative 3/2 y minus 6. Here is our sub. And we are going to plug equation 2 into equation 1 for x. So plug x into equation 1. Here we go. 5 times my new x value of negative 3/2 y minus 6 minus y equal to 21. So we took equation 2, plugged it into equation 1, and now we're going to solve for y. Distribute that 5. You'll get negative 15/2 y, not plus, minus 30 minus y equal to 21. Okay. Put your like terms together, and I'll have negative 15/2 y minus y. Just rewrite it. Why not? Minus 30 equal to 21. We'll add that 30 over. And at negative 15/2 y minus y, add that 30 over, you get 51. Okay, so all we have to do here is combine our y values. So some fraction side work, right? Negative 15/2 minus 1. You put 1 over 1, get your common denominator of 2. That gives me negative 15/2 minus 2/2. I get negative 17/2. So that's what's going here. Negative 17/2 y equal to 51. Okay, almost there. Now you can divide both sides by 17/2 or multiply by the reciprocal, which is going to be a lot easier. Multiply this by negative 2 over 17, negative 2 over 17. And once we do that, cancel, 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 cancel. You're left with y equals 51 times negative 2 over 17. Well, 17 goes into 51 3 times, and y is just going to be negative 6. All right. So there we go. We found y. Now the next step is to solve for x when y is negative 6. Okay. And once again, this is the easy part because we already made a substitution for x. So that's the equation we're going to use. We get x equals negative 3/2 times our y value of negative 6 minus 6. Clean it up. Negative 3/2 times negative 6, that'll be positive. That becomes 18 over 2. So 9 minus 6, and x equals 3. Done and done. And now, once again, when stating our solution, it's going to be 3, -6. At this point, both functions intersect. Okay. All right. That is the substitution method. Once again, take equation 1, rearrange it for x or y, plug it into equation 2. Or take equation 2, rearrange it for x or y, and then plug it into equation 1. Any questions on the substitution method? Is everybody good on the substitution method?
On the substitution method, sir, do we just take the hardest and plug into the easiest, or easiest into the hardest?
You plug, to make your life easy, you plug easy into easy.
Oh, of course.
So number 2, I just wanted to make your life more difficult. We could have rearranged 5x minus y, solved it for y, and plugged it into equation 2. But like I said, I wanted to mix things up and show you that, hey, I can take equation 2 and plug it into equation 1. So either way it works. But if you see an easy one to rearrange, that's the one you want to make into your substitution. Like
Right,
we did for the first example. Yeah. All right, cool. All right, the next method is elimination method, and this is the best method. It is the fastest because you get to eliminate a variable. And the best part about this method is that you get to manipulate both equations by whatever numbers you like, as long as it will eliminate a variable. So what we do in elimination method is we look at equations 1 and 2, and we say what variable we want to eliminate. And once we figure out what variable to eliminate, we want to say, well, what could I multiply equation 1 by? And what could I multiply equation 2 by to help me get rid of x or y? So looking at these equations, I see that I have a positive x and a negative x. So when you do elimination method, we add the equations together. And when we add them, a variable must eliminate. So it helps out when one variable is positive and the other is negative already. So for this system, I'm going to say I want to get rid of the x's. So to do that, I need to multiply this bottom equation by 2. And the reason we're going to manipulate it by 2 is because when I add it together, 2x plus negative 2x should cancel. So this is what we're going to do. I'll pull these out. 2x plus 3y equal to 1. And then negative x plus y equal to -3. Now I said I wanted to eliminate x. So that means that this equation, the second equation, is going to get multiplied by 2. And then our next step is the first equation stays the same. But now the second equation, everything is multiplied by 2. -2x plus 2y equal to -6. And now we are all set up to eliminate x. And what we're going to do is add the 2 equations. So 2x plus -2x will cancel. 3y plus 2y will give me 5y. And 1 plus -6 gives me -5. And then divide by 5, and y equals -1. Now tell me how much faster that was. Was that a lot faster than substitution? Of course, we're not done, but that was definitely a lot faster. And you get to choose which variable you want to eliminate. We could have said we wanted to eliminate y. If we wanted to eliminate y, I would have multiplied the second equation by -3 and then added them. So elimination puts a lot of power in your hand. It looks like it's sunny. If you want to move them in, you can. Up to you. All right. And then for this next part, since we have y equals -1, you can now plug it either into equation 1 or equation 2 to help you solve for x. It does not matter. You'll get the same answer. All right. So you get 2x plus 3 times -1 equal to 1. And then 2x minus 3 equals 1. Add the 3 over. 2x equals 4 and x equals 2. And there it is. So our solution is the point 2, -1. Okay, and that is elimination method. So first thing you should do, pick a variable you want to eliminate, and then figure out how to manipulate both equations, maybe just one equation, to eliminate that variable. Everybody good with this one? Where are those thumbs? There we go, one thumb. 2. All right. Again. 2. 3x plus 3y equal to -1, and 4x plus y equals 8/3. Okay. So here, once again, since we're using elimination method, pick a variable you want to eliminate. And Pete said, eliminate y. Let's do it. So we're going to eliminate y. So let's bring these equations out. 3x plus 3y equal to -1. And 4x plus y equal to 8/3. So if we want to eliminate y, what would I multiply the second equation by? -3. Good. And this means I'd get 3x plus 3y equal to -1. My new equation is -12x minus 3y equal to -8. And now we see that when we add our equations together, 3x plus -12x will give me -9x. 3y plus -3y will cancel. And -1 minus 8 gives me -9. Divide by -9 and x equals 1. Okay. And now, since we have x, all we have to do is solve for y when x is 1. And again, you can plug it into any of these equations and you'll get the same answer. Well, you're probably saying that the first one looks better. So we'll use that. So you get 3 times 1 plus 3y equal to -1. You get 3 plus 3y equal to -1. Move that 3 over. You get 3y equals -4. and y equals a negative 4/3. And there's our solution. One comma negative 4/3. And that's elimination method. No wrong way about it. Just watch your algebra and watch your science. And elimination is definitely way faster than substitution. Any questions on this page?
Could we use elimination method by substitution method?
Say that again.
So instead of utilizing substitution method, could we use elimination method?
Yeah. Either one, either method you choose works. So if you love substitution, use substitution. If you love elimination, use elimination. I think your homework says, well, maybe you might have some substitution only, but some of your homework problems say use substitution or elimination method. So that's nice. Okay. All right. Now, this next page, let's see what an inconsistent system and a dependent system looks like. So here, an inconsistent system of linear equations. We're given 2x plus y equals 5, 4x plus 2y equals 8. Let's go ahead and solve this by elimination. 2x plus y equals 5, and 4x plus 2y equals 8. Let's go ahead and get rid of, let's say y. And if we want to get rid of y, we're going to multiply the first equation by -2. All right, which means that the first equation will now become -4x minus 2y equal to -10. The second equation stays the same. 4x plus 2y equal to 8. Now we're going to add these two equations together, and we see that my x's will cancel, my y's will cancel, leaving me with 0 on the left side. And then on the right side, we end up with -2. Is that a true statement? Does 0 equal -2? No. Pete said red X. That is not a true statement. Therefore, this system is inconsistent, which means it has no solution. This means that your lines are parallel. If you were to solve this by graphing, the first equation would be y equals -2x plus 5. The second equation would take a little bit of work. 2y equals -4x plus 8. Divide by 2, and y would equal -2x plus 4. We see that these two equations have the same slope. And if two equations have the same slope, this means that when you graph them, they will be parallel. Good. What would that look? That's negative slope. So they would look something like that. Boom. All right, cool. So that's inconsistent. Now let's look at dependent. Here you have 2x plus y equal to 4, -6x minus 3y equals -12. And again, let's solve this by elimination. So let's get rid of a variable, and this time, let's say x, which means I'll multiply the first equation by 3. And I'll get 6x plus 3y equal to 12. And then I'll get negative 6x minus 3y equals negative 12. And here we see that when we add these together, your x's will cancel, your y's will cancel, leaving you with 0 on the left side. And then your constants will cancel, leaving you with 0 on the right side. So 0 equals 0. Is that a true statement? Yeah. Ooh, man, it's coming down. All right. So since that's a true statement, this is a consistent system. And this means that you'll have infinitely many solutions. There we go. So those are that is an inconsistent system, and that is a dependent system. Oh yeah. And if you rearrange both of these equations, they are going to be the same. That one's y equals negative 2x plus 4. This one's negative 3y equals 6x minus 12. And y equals negative 2x plus 4. They are the same. So those are your dependent equations. All right. Everybody good with that page? Ooh, buddy.
I'm good with it.
You're good with it? All right. So next is a system containing 3 equations. All right. All right, Carl, I'm gonna let you jump in because I think the wife wants me to move the cars.
All right. I'll take this over then. I'll try to
Yeah.
go slow.
Copy link. Copy and go to Carl. There you go.
All right. Good stuff. Let's close that. Minimize my OneNote. I'm gonna share. Yep, that's fine. Share this screen there. Wait. Yeah, let me.
Yep. All right. I'll be back.
All right. Good stuff. Maximize this. Minimize that. All right, and we are on. Ooh, it's a bunch of lightning. Let's see, is this the right one, or is it the top one? I think it's normally the top one. All right, cool. There we go. All right, I will try to show you both ways. We'll do it with substitution and with elimination. So let's do elimination first, because that's usually a little bit easier to do. The right size pin now. Cool. Okay, so when you do 3, right, you have to make multiple steps. So you kind of have to do them all at one time, right? When you do the elimination method. So let's do x plus y minus z equals -1, 4x minus 3y plus 2z equals 16. And then we got 2x minus 2y minus 3z equals 5. Okay, so we can multiply these by any number we want, and it's all going to work out, right? So we can multiply all three of these by any number we can try to figure out to eliminate one variable at a time, and then we just continue that process, right? So how about, let's see, which one looks easy? What if we do the top one by, you know what, now that I'm thinking about this, this may be a little too difficult of a situation for elimination, right? Because let me walk you through why. Sometimes it's education, we'll see why. Say I do -4 up here, right? And I'm gonna focus on just the x's, and then I can do -2 down here, right? Then we get -4x minus 4y plus 4z equals 4. 4x minus 3y plus 2z equals 16. And then we get -4x plus 4y plus 6z equals, what would that be, -10. Okay, here's the problem. Do you see if I try to add all of these together, what would happen at the end is I would eliminate, like say, we could eliminate this one and this one, and then our final product, right? If we look at everything that we would get here, right, we would also break these down. We would get -4x minus 3y, and then we've got 10, 12 z equals, what is that? 20 minus 10 is 10. So we haven't eliminated any variables. So we would have to find one number we could multiply it by to get through it every step. And it's just not going to work with 3 of them, right? So elimination doesn't work here.
I have a question.
Uh-huh.
Are we limited to having to keep one of the equations original, or can we change all three of them?
So when you do elimination method, right, you can change all three of them potentially, but here's the problem, right? When you look at this, if you make so that you add the equations together, right, no matter what, wouldn't it be the case that every time you get a minus, a plus, and then anything else when you're trying to eliminate one variable? So anytime that you have 3 sets of equations, you can eliminate all 3 variables.
Okay.
Does that make sense?
Yes, because I was thinking, I mean, we could multiply the 2 to the middle equation, make that an 8x, and then that would zero out the x's. But then I kind of see what you're saying about train of thought
You
there.
know what? I see what you're saying. Yeah, why don't we try that real quick? Let's give it a try. Maybe that's something that'll work. And we'll let's multiply this by 2 then. Let's see what we get. Okay, so then we'll get, this is 8x minus 6y plus 4z equals 32. And let's see what we get here then. We would have 0. Let's come over here and erase this. Okay, so then we have, this is -6y, and this is plus 14z equals, and then we would get was 26. So here's the next problem. We don't have anything else to eliminate with, right? Because now we're in a system of 2 equations, and we can't, or 2 variables, but we can't eliminate anything else. So what we're going to end up having to do here is solve for one of these variables and then do substitution anyway. So in this case, elimination I don't think will work. So let's just do the substitution method. So instead, let's try substitution. Okay, so when I do these, I number my equations. We got x plus y minus z equals -1. 4x minus 3y plus 2z equals 16. And 3 will be 2x minus 2y minus 3z equals 5. Okay, and then when I show this work, just so it's easier to read, it helps not just you organize, but it's going to help the professor grade. I will write things like this. So the first thing I'm going to do is I'm going to eliminate between 1 and 2, right? So I'm going to stack x plus y minus z equals -1 and 2x minus 2y minus 3z equals 5. And sort of what I'm trying to show you here by showing you that the first step, like a whole go elimination, doesn't work, and we get down here where we need substitution, right? Over here, you get the same problem if you start with substitution. You have to go to an elimination step at some point. It's just generally easier when you do sets of the complex systems to start by eliminating the smaller subsystems and working through them down, because that way you can get it down to maybe just one variable really easy. So we're going to go here and I'm going to eliminate, I'm going to multiply the top one by 2 and just knock out y. So we'll do this by 2, and we'll get 2x plus 2x is 4x, plus 0y. Negative 2z minus 3z is -5z. -2 plus 5 is 3. All right, so this gives us then 4x minus 5z equals 3. And I'm going to call this equation 4. All right. So at this point, I could solve for x or z, and I could plug it back into one of these other equations, right? So I could take, I could solve this down to just an x variable, and I could plug this back in over here. But do you see how that would leave me with like a fraction in there? Let's try to avoid getting fractions, right? Because regardless of which one of these variables I solve for, I'm either going to have to divide by 4 or -5 to get this variable by itself. And none of the other numbers are divided evenly by 4 or 5. So I'm going to get fractions in there. So let's try to avoid fractions for right now. So I'm going to leave this 4 alone, right? And I'm going to go back and I'm going to eliminate between, let's do 2 and 3. Do I want to do 2 and 3? I don't want to do 2 and 3. And here's why I don't want to do 2 and 3. 2 and 3, because I have to eliminate for the same variable that I eliminated for in the first round. We got rid of y in the first step. 3 and 2 is gross. Let's instead do 1 and instead of 1 and I did 1 and 3 the first time. I'm going to do 1 and 3 now, or 1 and 2 now. I did 1 and 3 the first time. My bad. So let's eliminate between 1 and 3. Okay. So then we will get x plus y minus z. I said 1 and 3. I meant 1 and 2. I'm sorry, guys. Okay. Equals -1. And then we'll get 4x minus 3y plus 2z equals 16. Okay, so we want to multiply this top guy by -3. Let's do -3. I was going to do the x's, so we're going to do -3. Actually, no, +3. What am I doing? Crazy. Okay, so we got 3x plus 4x is 7x, 0y, -3z plus 2z is -z, -3 plus 16 is 13. And then we've got, this will be equation 5. And we'll come over here and I will eliminate for 5. So let's stack this in here. We've got 4x minus 5z equals 3. And we've got 7x minus z equals 13. Okay. So which one of these is easier to eliminate? Why don't we do this one times 5? Okay, so then that would give us 4x plus 35 is 39x. Sorry, this needs to be negative. Woof. I done goofed. This is not. This is negative 35 plus 4, 31x. The z's eliminate. This is going to be equal to, this is 13 times 5. Well, let's see. Negative 5 times 10 is negative 50. This is 65. This is gross. This is x is equal to negative 65 divided by, oh, it is. It would be negative, wouldn't it? This is gross. Okay. Actually, this may work out. Okay. So we've got.
It's 62, right?
Negative 62.
Negative 62.
Look at that. So x, 62 divided by 31. Look at that. Both negatives. X is just equal to 2. Easy peasy. So this will be 6. Okay. Now we can take this 6 value and we want to walk it back up the elimination steps we've done back substituting, right? So I'm going to take this x right here. So I'm going to sub 6 into, I can pick 5 or 4. I'm going to pick 4. All right, so we get 4 times 6 minus 5z equals 3. So this
It's
is
4.
20.
It's 4 times 2, Carl.
Oh my gosh. Thank you guys so much. I just want to let you know, I'm like a 3.7 GPA student. If I can do this shit, you guys can do this shit. I'm a mess. And if I can do this, like you guys
I don't think
can definitely do this.
anyone here is doubting your GPA, man. You're just you're speeding up.
All right. We got 8 minus 5z equals 3. Right. So this will be minus 5z equals what? Negative 5? Yeah. So z is just equal to 1. Okay. Now I can take, this will be 7. I can take 7 and 6 and plug them back into any of the other 2 equations. I have to solve for y. That will solve for y for me. So let's sub, let's just pick one because that's easy. Let's sub 6, 7 into 1. That's the easiest. So 6, x is equal to 2 plus y minus z is equal to 1. And this is equal to negative 1. So we get 2 plus y plus 1 equals negative 1. This is, what do we get here? This is 3. If we subtract 3 to the other side, negative 3 minus 1 is negative 4. All right.
Isn't z just 1?
Turbo math. Turbo.
Minus 1. All right, so this is just 1 minus 1, negative 2. Okay, so we get x equals 1, y equals negative 2, and z equals 1. All right, and there's our answer.
X equals 2, Carl.
X equals 2. Holy crap. I promise you guys, I promise you, if my absolute ADD mess of a brain can do well in school, please never doubt yourselves. Holy crap, I'm so sorry. So, it's a mess. Long story short, when you do anything that has more than just 2 variables, it gets complicated very, very quickly, and it gets messy very quickly, and you have to throw in a lot of steps, and you're going to need both elimination and substitution to solve through it if Robert isn't nice enough to just show you how to put this into a matrix and then solve it with a calculator.
Woo! Woo!
All right, that's that. You want me to do the next one?
If you want, up to you.
Why not? Let's try to redeem myself here. Okay. So rewrite my equations. X minus 2y plus 3z equals 7. 2x plus y plus z equals 4. Negative 3x plus 2y minus 2z equals negative 10. All right, so again, we're gonna work our way down. Let's start with individual elimination. Which one looks easiest here? Well, why don't we get rid of y? Because y looks like it's gonna be the easiest to get rid of again. So let's go with, or you could start, no, because it's got a 3 and a z. Y's look the best. So let's eliminate y between 1 and 2. So with 1, 2. So we get x minus 2y plus 3z equals 7. 2x plus y plus z equals 4. Multiply this, not that one. I'm getting rid of y. Multiply this one by 2. All right, so this would be 4x plus an x is 5x. Our y's go away. 2z plus 3z is 5z. 2 times 4 is 8, plus 17 is 15. And this is equation 4. All right, so then we want to do the same. Eliminate y between 1 and 3. Holy crap. My brain has been real ADD today. I'm sorry, folks. All right. X minus 2y plus 3z equals 7. Negative 3x plus 2y minus 2z equals negative 10. We don't have to change anything. Negative 3x plus x is negative 2x. Our y's eliminate. This is plus 3z. Nope, plus just z. And then this is negative 3. Okay, and then we get equation 5. Okay, which one do we want to? Let's eliminate z. Eliminate z in 4 and 5. So we get 5x plus 5z equals 15. Negative 2x plus z equals negative 3. Uh-oh. Does that mean this? No. Okay, we're good. We're good. Never mind. I thought we were going to have a problem. So we want to multiply this by 5. All right, so we
Negative
get
5.
negative 5. It is negative 5. So you get 10x. 10x plus 5x is 15x. Your z's eliminate. And then negative 5 times 3 is 15, plus 15 is 30. If you divide 30 by 15, then x will equal 2. And this is equation 6. All right. So now, again, back substitute backwards. We're going to go back and put this into equation 5 looks easier. Plug 6 into 5. All right, so you get negative 2 times 2 plus z equals negative 3. So negative 4, add 4 to the other side, you'll get z is equal to 1. All right, so then let's plug. This is 7. 6, 7 into, which one of these looks the easiest? It doesn't really matter. Let's do 2. 2 looks the simplest. Fewest coefficients. So we get 2 times 2 plus y plus 1, just 1, is equal to 4. So 4 plus y plus 1 equals 4. The 4's cancel, subtract 1 to the other side, y is equal to -1. So our final answer is x equals 2, y equals -1, and z equals 1. There we go. All right, minimal errors that time. Good stuff.
All right.
Any
was
questions on
fun.
any of that? I'll take that as a no.
You got it. Show them your thumbs.
Yeah, thumbs, yeah.
Yeah.
All right, good stuff.
Oh, we got a
Okay.
thumb. Okay. That
take this.
concludes 12.1. Now let's do 12.2. So I'll start a new video for that.